students. Today we are going to discuss about the thermal resistivity in solids, especially in solids. Already in previous classes we studied that the conductivity is mainly due to electrons in conductors, and whereas phonons in case of insulators. So electrons are responsible for the thermal conductivity in case of conductors. Phonons are responsible for the thermal conductivity of insulators. Especially in case of insulators, the energy is carried out by the phonons. So what is meant by phonon? Quantized lattice vibration is a phonon. So every atom about their mean part, they vibrate and they generate phonons. So these phonons, so different atoms will generate different phonons having different frequencies. So these lattice vibrations itself are called phonons. So these phonons will carry the thermal energy and they will conduct the current. So this is called thermal conductivity. So for every action there is an opposite reaction according to Newton's law. This is also holds good in solids also. As these phonons are carrying the thermal current or carrying the energy, some resistivity is opposing to reducing that conductivity. So what are the three important points used to reduce the conductivity? First point is, so each two phonons, these phonons will interact with each other. So the interaction of phonons will take place. So this process is called as clap process. The one phonon carrying thermal energy, second phonon is also carrying thermal energy. Similarly, next phonon is also carrying thermal energy. When they are carrying the thermal energy, these phonons are interacting with each other. They are reducing the thermal conductivity, gives rise to thermal resistivity. And second point is scattering of phonons at boundaries. These phonons for example, this is the total crystal. These phonons, while traveling, they are scattering at these boundaries. So due to that also the thermal conductivity decreases, which can arise the thermal resistivity. And third point is impurities present in a crystal. What are impurities? So due to the application of temperature, the atom may displace. Some of the atoms may get energy, they may displace. There may be a formation of holes, as in the case of electronics. So which is not a perfect crystal. There are some imperfections or some impurities arises due to increase in temperature. So these three important properties will give rise to the thermal resistivity. First point is interaction between phonon and phonon, called as clap process. And second one is scattering of the phonons at the boundaries of this lattice, gives rise to thermal resistivity. And third point is impurities present in that crystal. So these 3 points will give rise to the thermal resistivity. So let these 3 resistivities are designated as Ru for the resistance arises due to clap process, that is phonon-phonon interaction. Next Rb, which arises due to scattering of phonons at boundaries. Next, Ri, resistance due to impurities present in that crystal. Ru is the resistance due to phonon scattering, called as Clap process. And the second one is resistance offered due to scattering of the phonons at the boundaries of the crystal called as Rb. Boundaries is B. U means Clap, I means impurities. So we all of us have studied the thermal conductivity is indicated with the letter K. So the inverse of this thermal conductivity is nothing but resistivity. So the resistivity of any material in a insulator is the sum of the inverse of conductivity due to Clap process, the inverse of conductivity due to boundaries scattering, next the inverse of the thermal conductivity due to impurities. This is nothing but Ru plus Rb plus Ri. This is the thermal resistance of solid, particularly insulators. The first one, Clap process. What is Clap process? So atoms vibrate and they will generate phonons. So two phonons having angular frequencies omega 1 and omega 2 will generate a third phonon of angular frequency omega 3. This phenomenon is called Clap process. Two phonons having different frequencies interacting with each other generates a third phonon of angular frequency omega 3. So similarly, this third phonon interact with the next phonon generates another phonon of frequency of different frequency. So this continuous process is called as Clap process. So this is the main important phenomenon in solids. Thermal conductivity. Along with thermal conductivity, there is thermal resistivity in a solid. Particularly in insulators, the thermal conductivity arises due to three different processes: Clap processes, scattering at boundaries, and due to impurities.